Alright, so we have to sketch this. Now this question asks you the sketch in 4 parts, but whether you're asked to do part A to C or not, you actually have to do it to be able to sketch the picture. Okay, the first step involves essentially analyzing the first derivative. Okay, actually, so that's part B. Right, you have to analyze the first derivative. Second part, you have to analyze the second derivative. Okay, and then you got to collect the information together, and I'm going to show you how to do that using a organized box, and you can sketch the picture. Okay, so step 1, let's actually step 1, the very first thing, you should actually analyze the function. Okay, what about the function? Well, you can read off, if you factor out x, right, you get 36 3x, right, minus 2x squared. You can read off the x-intercept and y-intercept. Okay, so check for x-intercept and y-intercept. Another thing you should look out for is symmetry. Okay, so if this was an odd power, this would be odd. This would be an odd function, but it's not. So this doesn't have any symmetry. So you don't have to worry about being symmetrical about the x or y axis. By x-intercept, you can see that x equals 0 is one x-intercept. Is this factorable? You can also get 2 more x-intercepts. Let's just use the quadratic formula. Okay, minus 3 plus minus 3 squared minus 4. A is minus 2 and C is 36, right? All over 2 times by negative 2, 2A. Right, so this is A, this is B, this is C. Okay. Okay, so that's minus 3 plus minus, what do we have in the square root? So this is 297 in here. Divided by negative 4. So let's get 2 of the x-intercept, and there's an approximation of with decimals. Okay, so these are the 2 values you get. These are approximation accurate to 1 decimal point. Okay, that's so we've done our job analyzing the first derivative. Okay, so y-intercept 2. Sorry, this is the x-intercept. Y-intercept is very easy. Set the x equal to 0 and you get 0, right? So you pass through 0, 0. That's good. Okay, step 2. Now you analyze the first derivative. Okay, so first derivative is going to be 36 minus 6x minus 6x squared. Let's factor out a minus 6 and you get, okay, and this does factor, plus 3 minus 2, set equal to 0. And you get x equals negative 2, positive 2 and negative 3 as critical numbers, right? Oops, sorry, I made a mistake here. It's plus 6, which makes that minus 6, which makes this should be minus 3, and this should be plus 2. Okay, plus, minus. Okay, so I'm interested in knowing when is this positive, right? That's the same thing as being interested in knowing when is this positive. Let's divide both sides by negative 6 and you get this. Nice factor form. It's going to be less than 0. This can be interpreted as a parabola with roots at negative 2 and 3. Okay, and it's negative right here, right? That means, okay, when x is between negative 2 and 3, the function is actually increasing. Okay, so this is a solution. This is a solution to this question right here. So in that region, it's increasing. Okay, so the critical numbers, right, it's negative 2 and 3, right? So here, let me try it. Negative 2 and 3. It's increasing here. Right, so it's increasing like this. And it's decreasing here and decreasing here. So this is going to be local minimum, this is local maximum. So let's find that out. Let's plug in -2 into the function. Alright, so these are the values I get when I punch in the calculator. Okay, so this is going to be the local minimum, this is going to be the local maximum. Okay? Now, let's do the second derivative. Okay, so second derivative, it's easiest to continue from there, not the factor form, the expanded form. And you get a 6 minus 12x. Okay. So let's ask, when is that positive? Well, minus 12x is greater than -6. Then x has to be not greater but less than half. So when x is less than half, it's concaving up. Okay, let's summarize all of this in a box. Okay, so I'm going to zoom that over here. I'm going to draw a box. The top row here represents x. Okay, I'm going to put -infinity at the end here. And I'm going to put all my critical numbers. And they are, so the numbers that you got from the first derivative as well as the second derivative. So they are -2, and then half, and then 3. Okay? Okay, and then I'm going to put all the information I know about the first derivative in the second row, and the second derivative in the third row. And then in the last row, I'm going to actually put down the values of y. Okay, and the last thing here is infinity. Okay, we found out between -2 and 3, the first derivative is positive. So it's positive here. These are zeros, and it's negative. Right? From right here. Okay, from right here, we found out that the second derivative is positive, less than half. So here it's positive. But here it's going to be negative then. True? Okay, we also found out at -2 it's -44. And at 3 it's 81. Okay, here, combine these two information. It's going down, but it's concaving up. So it's got to look like this. Okay, same here, right? So here it's going up, and it's concaving up. So it's got to do this. Here it's going up, but it's concaving down. Do you see it? That actually matches the inflection point. And here it's going down. Okay, it's going down, but it's concaving down. So it's got to look like that. Okay, so I just punched the half into the original function. I got 18.5. Okay. All right. So look, let's sketch this. We're ready to sketch this now. It's going to be a little bit rough. Okay, a rough sketch. Okay. Now the scale is really off between x and y, right? The numbers along the x-axis are really small. The numbers on the y-axis are huge. So I'm just going to do it approximately, okay? So let's say at 3, so let's say that's about 3. We're all the way up at 81. Let's just say that's 81. At -2, and half will be right there. At half it's 18.5, so let's say about there is 18.5. -2 is -44, so let's say about there is -44. Okay. Alright, look. -44 is a minimum. This is the maximum. And this is an inflection point. Okay, and we also know it passed through the origin. Right, from earlier. Okay, so it's going to do something like this. Pass through the origin, concaving down, but then it's going to start concaving up from here. Okay, And then we're going to go down this way and go up this way. This is the shape of the cubic function, right? You guys already know that from hopefully from advanced functions. And we had the x-intercepts, so that must be negative 3.6 or 3.6? Yeah, 3.6, and this must be 5.1. So it's much more detailed information compared to what you guys drew in advanced functions.